Imagine, just for a second, that you could perfectly clone human expertise. Think about taking the hard-earned wisdom of a seasoned professional, all those years of trial, error, and intuition, and replicating it endlessly. And doing it all without writing a single line of impossibly complex, rigid computer code. Sounds like magic, right? Well, it's actually pure logic. And that's exactly what we're going to unpack in today's explainer. We are decoding the fascinating world of expert systems, taking these big concepts and turning them into clear, everyday insights.
So let's dive right in with a pretty wild question. How do you actually clone an expert? Seriously, picture the absolute smartest doctor you know. Or maybe that brilliant master mechanic who just listens to your car's engine for 2 seconds and knows exactly what's wrong. Now imagine taking their brain, their very specific ways of solving unique problems, and somehow bottling all of that up into a computer program. It absolutely sounds like something out of a sci-fi movie, but the truth? It's not fiction at all. It's a very real, incredibly practical branch of technology that's been quietly running in the background of our lives for decades.
Now, what's really interesting here is how surprisingly simple the core idea is. When we talk about an expert system, we are not talking about some self-aware robot trying to take over the world. We're really just talking about a digital apprentice. It's a computer program specifically designed to mimic human thought and emulate the decision-making of a professional, but, and this is key, only within a very specific domain. It doesn't know everything about everything, it just knows a whole lot about one particular thing, using a massive base of knowledge to solve complex problems and give you accurate advice, just like a seasoned human expert would. To really get how this works without getting completely bogged down in technical jargon, I love this analogy. Basically, an expert system relies on 2 main components. First, you've got the knowledge base. Think of this as a massive, meticulously organized library. It's packed to the ceiling with all the facts, rules, and historical experiences of human professionals. Second, you have the inference engine, and you can think of this as a tireless, brilliant detective. The detective doesn't just sit there staring at the library shelves, it actively reads the rule books, applies logic, and connects the dots to actually solve your specific case. And if we expand on that, we get our complete digital office setup. We've got our library and our detective, but for this office to actually work for everyday people, we need 2 more things. First, the user interface. Think of this as the friendly receptionist at the front desk. It's how you intuitively hand your problem over to the system. Second, and honestly maybe the most important part, is the explanation module. This is all about transparency. It's like the detective coming out of the back room and saying, here's exactly how I solve the case step by step. It shows you the math behind the recommendation, which is absolutely crucial if we're going to actually trust the system's advice.
Okay, so how does our digital detective actually think? Well, instead of relying on incredibly rigid, traditional computer programming where every single tiny step has to be perfectly mapped out in advance, expert systems do things a bit differently. They mimic human thought by using rules of thumb. Imagine a massive cookbook of if-then recipes, like if a patient has a fever and if they have this specific rash, then consider this specific treatment. This kind of rule-based logic is what lets the system adapt to different scenarios, analyzing the clues to arrive at a solution, very much like a pro adapting to a fresh problem on the job.
So we've got the theory down. We know about the library and the detective, but let's bring this into the real world. Where do these digital apprentices actually clock in every day? You might be surprised to find out just how deeply embedded these systems are in the tools and services we use all the time, streamlining decisions in ways that directly impact us.
The crucial takeaway here is that these are not just whiteboard theories. We are talking about proven, heavy-lifting workhorses. Take Mycin, for example. That was a pioneering system that actually standardized medical care by diagnosing infectious diseases and recommending treatments. Or Dendrol, which literally helped chemists identify completely unknown chemical compounds. Over in manufacturing, a system called XCon let completely non-technical people instantly customize highly complex computer setups. And, of course, IBM Watson, which famously crushed human champions on Jeopardy before taking its talents to everything from healthcare to high finance. These systems have been putting in the work for a long time.
But hey, it's not just historical milestones or massive industrial giants. These systems are your everyday problem solvers right now. When you log into an app and instantly get personalized financial planning or a risk assessment, that's an expert system. When you're chatting with 24/7 customer support that miraculously troubleshoots your exact super specific issue, or when a digital tutor perfectly adapts to your learning pace, yep, you're interacting with an expert system. They are constantly grinding behind the scenes to optimize our daily lives. However, there's a massive, fascinating tension at the absolute heart of this technology. On the one hand, you have these unbeatable advantages. You've got a digital worker with a flawless memory that never needs a coffee break and runs on endless 24/7 energy. But on the other hand, you have a major catch. This brilliant system has absolutely zero common sense. It is the ultimate specialist, but a complete novice at just being a regular human being in the world.
Let's look a little closer at those unbeatable perks first. One of the biggest game changers is knowledge retention. Think about it. When a brilliant human expert retires, their wisdom doesn't just walk out the door to the golf course anymore. It is permanently captured in the knowledge base. Plus, because it's a machine, it delivers 100% consistent decisions. It doesn't get emotional, it doesn't get tired, and it never just has a bad day. It gives you lightning-fast problem solving and easily scales up to crunch massive amounts of data all at once, which, as you can imagine, saves organizations a ton of money.
But let's pause for a second. We need a reality check here. Building these things is not a walk in the park. Gathering that initial knowledge, literally sitting down and extracting every single rule of thumb from a human expert to build the library, is an incredibly expensive and daunting task. Furthermore, because our digital detective relies entirely on the rules it was given, it's incredibly inflexible. If a novel surprise pops up that isn't in the rulebook, the system just breaks down. And perhaps the most dangerous part, bad data in means bad advice out. If the initial info is flawed, this system will highly efficiently and very confidently give you the completely wrong answer.
Which brings us to one of the most ambitious initiatives out there, the Psych Project. Because expert systems struggle so much with ambiguous, messy, context-heavy situations, the Psych Project has been trying to do what many people consider totally impossible, creating a knowledge base that actually teaches a machine basic human common sense. They are trying to emulate human-like understanding across a massive range of everyday topics. And honestly, it just goes to show that crossing this common sense gap remains one of the most formidable hurdles in all of artificial intelligence.
And that leaves us with an incredibly practical real-world question to end on today. As we increasingly hand the keys over to these brilliant, sleepless digital apprentices to diagnose our illnesses or manage our retirement funds, we hit a really tricky situation. If a system gets fed incomplete data, or a rigid rule misses some vital human context and it makes the wrong choice, who actually takes the blame? Is it the human expert who provided the knowledge, the engineer who built the engine, or the hospital or bank that deployed it? It's a complex accountability puzzle, and we're going to have to figure it out as these systems become more and more a part of our daily lives. Thanks for hanging out with me for this explainer. I really hope it gave you something new to think about.